Okay, you guys tell me, some of these you already know. Just a couple properties of definite integrals. Remember that when we're calculating an indefinite integral, same thing as an antiderivative, then we're getting back a family of curves, right? That's calculus jeopardy. But definite integrals are giving us areas under curves, so we should expect to get back numbers for answers, right? So a couple properties here. You tell me what these are. Just study. We haven't talked about this one, but you already know it, I promise you. What is that?
Exactly 0.
0, how come?
Because it's just from A to A, which could be
Yeah, so right.
both of the quantities subtract from each other.
Okay, good. So we're going to end, if you think of this in terms of an area, we're adding up the area under the curve f of x from x equals a to x equals a. So there's no width to the interval. So there's no area, right? So you don't even have to do that. I mean, you know, the math would bear that out if you did the calculus. It would be a waste of time. If you just think about what that means, anything like that is always 0. How about this? What happens if I flip the limits of integration? Okay, so I'm going to get, okay? So if we reverse the direction in which we're reckoning area, I know that sounds like it's kind of a little prospector or something, but that's how we say it in math. If you reverse it, when we reckon area, if you reverse the direction, it changes the sign of the area, okay? Left to right we consider positive, right to left we consider negative, okay? So we talked about that. Already know those. How about this one? What if we I always use a C. Yeah, I'm going to use a C also. I don't know why. What's that going to be? A to B. Yeah. Very good. And then we did, well, you already know this one. This is a minor leaguer. You know this one. What can I, of course, do with a constant if it's inside of a definite
Pull it
integral?
outside.
Yeah, pull it outside. And I won't even write this one down. What if I had a definite integral of the quantity f of x plus g of x dx? What could I do?
2 separate.
Split them up. Yeah, we could always integrate term by term, right? We could break them into separate, smaller integrals. Okay, I won't even write that one down. Okay, and then the last couple. One of these we did. Oh, did they not show stones in here? Well, I'm going to show you. Anyway. Oh, why did they show this? Well, anyway, what about this? We talked about this yesterday too, or Tuesday. What if we've got the integral of f of x dx from negative a to a, where f of x is odd? What is it?
0.
0. Yep. If we integrate an odd function over symmetric limits of integration, it's always going to add up to 0, isn't it? We're going to get exactly as much under the curve as we get over the curve. Or over the x-axis is under the x-axis, right? Okay, what about this one? Here's the one that we didn't do. Let's see if you can, oh, This one wrong thing. Yeah. Okay, so what about this? What if we did do this where f of x is even? Good. Okay, now think about this. If we were to graph, let's take an example of an easy even function like x squared, right? If we want to add up the area under x squared from negative a to a, well, wouldn't you agree that this area right there is going to be the same as, if I'd drawn it properly, as that area right there? Okay, so what we could do instead is we could double the area under the curve from 0 to a. Now that may not mean a lot to you right now, but that's a big advantage. Having a 0 there is helpful, right? Because when you evaluate the antiderivative from a to b, or in this case from 0 to a, well, isn't it easy to evaluate stuff at 0? I mean, usually what happens at 0 is the function goes to 0, right? So that makes life a lot easier too, okay? All right, one other thing I want to show you is on your calculator, there's a little trick that you should know about. I showed you how to calculate definite integrals using the graphing portion of your graphing calculator, right? You guys remember how to do that?
There's one for this too.
Yeah, there's one for, there's a way you can do this non-graphically. Okay, so here's the graphical way, right? We had x, like we did that one, for example, right? If we want to, here, let me make this bigger. Right, so if I want to graph this function, and I want to add up the area, what do we do? If we want to add up the area, second calc, if I go 7, that's how I add up the area. I just type in the lower limit. Let's go from -2 up to +2. So my upper limit will make +2. And there it is, right? It adds it up, okay? Another way you can do this, if we want to add up the area under, for example, like up here, under x squared minus 1. Did I show this to you?
Mm-mm.
I don't think I did. If you want to add up something like this, all you do is you go to the math menu and you go down to number 9, which is finite integral. Okay, so, and then look, it gives you the template, and so I put my lower limit in. You know, you can take it from here, I'm sure. Upper limit, you fill in the integrand, whatever the function is. We'll just do x squared. And then the variable of integration, which is going to be an x. And there you go. Right? Okay. All right. You're good. Work.